All right, everyone. Thank you for dropping by or watching this video, basically. Yeah. So today we're going to be going over tutoring worksheet number 4, which is which basically can be like divided into 2 parts. The first part is about time complexity, and the second part that we're going to discuss the questions of today is more about inheritance and also dynamic versus static type. All right, let's get started. Yeah. So this question is asking us to evaluate all the lines in our main function, or like in our main in our main program, right? And then we have to identify whether all these values either run normally, just compile basically, right, or whether we are going to run into any compilation errors. And here we need to identify what each line prints, or if it runs into some runtime error. All right. So what we see here is that we are working with 3 different classes, right? We were working with class A, class B that extends from A, so basically inherits from A, right? And then class C extends from A as well. And we can basically show that in some mini pedigree, the relationship between the 2 classes, or like the 3 classes here, right? So what we see here is that A is the superclass, B inherits from A, and C inherits from A, right? So B has access to all the contents of B and A, and C has access to all the contents within C and A. But B and C don't have access to each other's classes, right? So they're like both their kids. They're like both like subclasses from A. And I always like to give like a real world example, right? It's really stupid, but like you can imagine that A is a fish, and then B would be a salmon, for example, and C is a tuna. So they both can do things that fish can do, right? Like swimming. But then salmons and tunas are not necessarily the same things. So that's a really nice example that I always keep in the back of my head when I'm working. Sometimes relationships can get quite complex, but like narrowing down to like some basic examples here is really useful, or is something that I find really useful. Yeah. All right, so we see that X has some functions here. I mean, class A has some functions here, so it has function X and Y given argument Z, which is an A object. All right, so if we look at class C, right, class C has the identical function of class A, right, X, public void, and there's no arguments in there. And this is an example of overriding, right? And overriding basically means that a function in a subclass is exactly the same as, or like the signature, like the whatever, outside of the body of what is happening inside the function, it's exactly the same. And that means that if you're calling this function X on a C object, then it's automatically going to overwrite this function here. So it's just going to evaluate this one. And here we're working with overloading, right? So overloading is, as you see here, that void Y Z, and then B is like, Z is an object of the class B. And here we don't have an argument. So it's not exactly the same, although calling this function Y also in some way is like, in some way like it overwrites it basically, right? But it's not exactly overwriting because you're not putting in the exact same arguments, and it's what we call overloading because it's not exactly the same due to the inputs that are different from your parent class, your superclass. All right, let's get started with evaluating our main program, right? So what we see here is that a variable E, which is an A object, is being bound to B, right? So during compilation, right, compilation is equal to static type. Our E object is an A, but we know that, the dynamic type, like when you're gonna apply functions to it, when you're gonna work with B, it's obviously B is a B object, right? So this just runs normally. All right, AF. So we see here, right? So C is like a tuna is a fish, right? So in a similar way, C can be seen as an A as well, right? So the compilation, the static type is going to be an A here, and then the dynamic type is a C. All right, so that compiles as well. All right, now we're going to look at G, right? G is during the static type, it's or like during compilation, it's being initiated as a B object, right? But now we're going to look at A. So a fish is not automatically a salmon. So in this way, similarly, it's going to give an error, right? Because it's not possible for A to be a B object. So you get a compilation error. So we can just erase that out. All right. Or maybe this is better. Just erase this. All right. In a similar way, if we were creating, as I said earlier, B and C don't really have a relationship with each other, right? So if we are making a variable H, which is a B object, and we bind a C object to it, it's going to complain as well because in no way they're really related, right? Or they have like the same parent, but it stops there. So that will also give us a compilation error. Like a salmon or tuna is not a salmon, right? So we can get rid of that as well. Right, now we're going to look at C or at I here. So I is a C object. And when you see like casting, what Java does is, okay, Java doesn't care anymore. It just trusts the user, right? So Java just trusts you and you say that A is a C object. So you would just cast it like that. And then Java will just take your word for it. All right. So static type is a C, right? And then your A object is obviously just an A object, right? Simple as that. So compiles. All right, now what we see here is we see J, and J is an object of the class B. But now you're casting it to an A, right? And as we saw earlier here, like in no way it's possible that like you're binding an A to a B, because as we said earlier, that not every fish is a salmon, right? So now we can just get rid of this as well. And then, yeah, let me see real quick. We're gonna look at this one here. Well, if we look at E, right, E is a dynamic type B. So if you're casting it, it wouldn't necessarily give you any errors, right? So what you can do here is it's just a normal BB. All right, so when I said earlier, right, so when Java runs in, like we check for all the compilation errors, right? During compilation error, we check for the static types if they match up with whatever the dynamic type is. And if it's casted, then we don't really have to worry about the static type. All right. But now we have to like think about runtime errors as well, right? So if we see that I is casted as a C object, right? But what we said earlier, right, is not that not every fish is a tuna or not every fish is a salmon, right? So even though you tell Java that, okay, trust me, I know what I'm doing, in fact, it doesn't make sense to establish this relationship. And during compilation, it might compile because you casted it right. But during runtime, it's going to find it out that this relationship is in no way possible. So now you're going to get a runtime error here. So we can just get rid of I as well. So yeah, I always like going over compilation errors first because that's what Java does first as well, right? And then if you're starting the program, then you're checking for runtime errors. Or that's like a personal preference, obviously you can just like do it in any sequence you want as long as you get the answer right. But I think doing it in the same order as Java does is really helpful, at least for me. Yeah. All right, now we're done with establishing whether what lines are actually evaluated and don't cause an error. We can just jump straight into the print statements here, right? Okay, so if we look at F, right, F is, so static types are mainly useful during compilation, right? And when we're using dynamic type, it's just like when you're using the functions on it. Like it just comes in play when you're like accessing functions or variables within there. All right, so if you look at F, right? F is a dynamic type of C. Oh, let me charge my iPad real quick. So we see here is that F is a dynamic type C, right? So we just go into C and we're going to look for a function X, right? It's right there, so we just print CX. All right, now we're going to go look at E, right? E is dynamic type B. Going to go into E. And in our class B, there's no X. So Java is going to look into its superclass, right? Because A is a superclass and we see X. So it's going to print AX. All right. So now we're going to look at EY, right? If we look at EY here, so E is a dynamic type B, a static type A. All right. So, normally we would be able to, since like one thought that a lot of students have is, okay, EY, E is a B object, right? So you'd be able to jump into E and then just print a BY because the function is there. Like that would be possible if our static type was B. But during compilation, what's going to happen is that because your static type is an A here, it's going to assume that this line here refers to an A object, and A doesn't have a function Y that doesn't take an argument. So this will actually cause a compilation error. Compilation error. All right, now we're casting this, but this is not really the right way of casting it. You're casting the whole function. So this would still give us some weird compilation error as well. We're basically attempting to cast a function. Like you can only cast, it would only make sense for us to cast like objects. So it causes a compilation error as well. All right, what's happening here is we're casting this as a B object. So during compilation, you tell Java, okay, I know its static type is an A, but I know its dynamic type is a B. And its dynamic type is a B, then Java trusts you and is like, okay, so we assume that its static type is a B here. And we jump in here and the Y function exists, right? So during compilation, it just compiles, and then during runtime, evaluates EY, which will print BY. All right, 2 more to go. So now we have E.YE, right? All right, because during static type, or static type is an A for E, right? So, and our E object is, so E object is a static type A and our dynamic type is a B object. So we're gonna look at this, right? And what is happening basically here is that you're gonna go into E as if it's a B object. And this basically, okay, a side note, this would compile because E is a static type A, right? So during compilation, it just assumes that it's this function. But during runtime, while we're evaluating this function, because it's a B, you're going to jump into B. And then you're going to apply, oh, why is it freezing? All right, yeah. So it's going to jump into E. And remember that static type of E is A, right? We're going to jump in here and you are going to, or a lot of students would automatically print BYZ. But that's not basically what's going on here because E has a static type of A, and you go into this function here, it basically will not recognize it because A is not automatically B, and not all fish are salmons, right? So it will assume that it doesn't find anything and would jump in here because E static type is an A, and then it will print out AY. All right. And now we have one more left to go, right? So F static type is an A as well, and its dynamic type is a C, right? But during compilation, it just compiles it and it just takes this function here, this significant function. Okay. And then we access this function in here, right? E.yf goes in here, goes into E's dynamic type class, right? It goes jump into B. We see that F static type is an A. It's not in here. Jump up here, and then we print AOI. All right. Now we're gonna jump to the next question, which is classy cats. Yeah, so this specific question is going over a public animal class. And this animal class has 3 variables, right? It has a name, a noise, and age. And during the construction of an animal, we can put in name and age, and then you will construct the name and age, right? And then noise can be huh. And then when it makes noise, it's just going to evaluate this function here. And when it greets, it's going to return its name with a colon and then the noise that it makes. All right. So this question is asking for, given the animal class, fill in the definition of the cat class so that it makes meow noise when greet is called. Assume this noise is all caps for kids, i.e. cats that are less than 2 years old. All right, now we have to implement a cat class here, right? So it extends from animal. So this relationship would be described as follows, right? We have an animal, and a cat is a type of an animal. All right, so we have a public class cat extends animal. Okay. So now we just have to make a constructor, right? So public cats, and a cat has a name and an age. Okay, so we can just basically use the constructor from the parent class, right? Using a name and age, right? Okay, that works well. But if you don't call it, if you, for example, just left it empty, then it assumes that, yeah, so if you're constructing, so this is what's going on, right? So if you're constructing a constructor for like a class that is inheriting from another class using extent, right? If you don't put in anything, like if you just left it empty, for example, if you just return nothing, right? Or if you just left it empty, right? It's just going to assume that you use this function, super, which is the null argument constructor, right? But in this situation, it wouldn't work out because animal class doesn't have a null argument constructor. The only constructor here is the constructor that has name and age. So that's why you have to call it manually super name and age. And this would construct an animal, right? But one other restriction that we want to have is that we also want to make sure that the noise is meow, right? And so we have to manually set this.noise equals to meow, which is basically the only thing that we have to do here. Yeah, is all caps for kins. So yeah, if we want to make sure that this is happening, this function is already instantiated in our parent class, that we don't have to worry about making everything uppercase if it's for kids, like cats that are less than 2 years old, because of this statement in here. So that's why this works particularly. All right. Now we're going to look at the last question here, right? So animal is an extremely broad classification. So it doesn't really make sense to have it to be a class, right? So now we create an abstract class. It has a protected string, name, and everything else is just the same here. Or has some methods in here, right? All right, now the question is asking us to fill out the cat class again below to make it compatible with animal, which is not an abstract class. So an abstract class does not have a constructor or anything, but it is able to construct certain functions, some default methods, as you probably have seen in your deck, right? In your deck's interface. Remember that you've been able to make a default implementation for some functions, right? This is the same thing here. It's a little less than a normal parent class because the constructors are left out. All right, so now we just basically have to implement these two lines here. And what I always like to do is looking at the function. So this function is saying that we're overriding, and overriding, as we saw earlier in question 4, basically means that the signature, like the type of function, whether it's public or private, whether it's static or void, or like whatever it returns, right? That should be exactly the same as your parent class here. So if we're overriding shout, then we can basically just copy this, right? But it's not an abstract implementation, so you can just make it public void, because this is the actual implementation of shout. All right, when we see our count, right, we can just make it void, and it will assume whatever it is. Yeah, like normally you would make it public, right? But since you didn't define public here, you can just leave that out. And abstract just means that the function is like left open for subclasses to implement how it's working. So yeah. So you don't have to type like write in public here. You can just leave it out to be very consistent, but you can just type in void. So for these kind of questions, when you're supposed to like write overriding like functions, you can just copy it, but then without the abstract here, right? All right, that's all I have today. Thank you for dropping by. And if there's any questions, feel free to like ask, on Ed.